Section 6.4, we will be graphing the sine and cosine functions. Let's just first take a look at the basic parent function for f of x equals sine x. If you'll notice, the first key point is that at 0, 0, so sine of x goes through the origin. And then this should make sense. I put the unit circle up here in the left corner so you can see that when we're at 0 degrees or at 0 radians, sine, which corresponds with the y coordinate, is equal to 0. Now the next key point is pi over 2, comma 1. That's because over here at our unit circle, remember sine takes on the y value of the coordinates on the unit circle. And at pi over 2 radians, sine is equal to 1. Then when we get to pi, we have pi comma 0. That's our next key point. Sine is back at the x-axis. And then 3 pi over 2 negative 1, which you can see over here. And then we complete one full cycle. Remember, the period of sine is 2 pi. So here are the 5 key points. 1, 2, 3, 4, 5. So when you're asked to graph, typically it's just one complete period, one complete cycle, and you'll need to label on the x-axis these 5 key values. And the y values are always in the same way, that it starts at 0 for sine, goes up, back to 0, down, back to 0. And then notice how far apart each of these key points are. That's what we call the step. Some books call it the increment. So they're pi over 2 apart, right? Do you see that? So the step is pi over 2, and the standard period is 2 pi. Okay, now if you notice, the max value is positive 1, and the min value is negative 1. So the amplitude is half of the difference between the max and the min values. So the amplitude is equal to 1. Okay, and then if you want to refer back to the chart that we had at the beginning of 6.3, you can see that we said the domain was all real numbers and the range was from negative 1 to 1. And this also is reinforced by the graph that we see here. And then make sure you put arrows on there extending in both directions, but don't draw an arrow going upward at this end, right? It's not going to extend higher than 1 in the range. So see how this part of the curve is sloping downwards. Make sure your graph looks like that. Okay, for cosine, it's pretty much very similar. The step and the period are the same. It's just been shifted pi over 2. Do you see that? So this has been shifted by pi over 2 to the left. And that's what that says right there, right? Remember our transformations? The graph of sine of x is the same as the graph of cosine of x, shifted pi over 2 to the right. Or basically just remember, when you're at x equals 0, the cosine graph starts up here at 1, right? Because of our unit circle. Let me scroll back up. Here's our unit circle. And when we're at 0 degrees, 0 radians, the x value is 1. So that's why cosine starts up here at the top. And then it proceeds the same way. So it goes to 0, down to negative 1, back to 0, up to 1. So those would be the 5 key points for the cosine graph. The step and the period are the same. Amplitude is the same. Okay? So the period is going to change for some of these graphs. The amplitude is going to change, and then we might reflect them. But we'll look at other transformations as we move into other sections of the book. So here's the basic steps, how to graph a sine or cosine graph. So determine the amplitude. The amplitude is the absolute value of A. So A, the constant out in front, you're used to this from our transformations before, right? That would indicate some sort of vertical stretch. So that would change the amplitude. If there's a negative sign, then that's a reflection. So when you're asked to state the amplitude, you give the absolute value of that coefficient. The period, some books call it T, whatever. You can just say the period equals 2 pi divided by omega. That should be like this kind of an omega. Whatever the coefficient is on x, okay? Then you divide the interval into 4 subintervals of the same length. Or another thing that I like to do, you just find the step, And the step is you take the period, once you find the period, and you divide it by 4. Okay, for all your graphs. For sine, cosine, when we do tangent and cotangent later on, you're always going to take the period divided by 4. And then you use the endpoints of these subintervals to obtain the 5 key points on the graph. I'll show you how to do that. Then you plot the 5 key points, draw a sinusoidal graph to obtain the graph of one cycle. Extend the graph in each direction to make it complete. Okay, so here we go. The process will get repetitive eventually, so that's good. And it doesn't ask for it, but we're going to state the domain and range just because it's excellent practice, and I know you guys love it. Okay, so graph the following functions. Be sure to label key points and show at least 2 cycles. You know what? We're just going to do 1. 2 is overkill. And then use the graph to determine the domain and range. Oh, they asked for it. Fantastic. Okay, so here we go. A is equal to -3, right? A is the coefficient right here. So that means the amplitude is the absolute value of A, which is going to be +3. Okay, so don't forget that that negative means we have a reflection over the x-axis. Okay, now let's see if there's been any change in the period. Is there a coefficient in front of x? Remember, if there's some constant in front of x, that's going to affect it horizontally. It could be a horizontal stretch or compression, but I don't see anything in front of there. So there's no change in the period. No change in the period. So that means the period is still equal to 2 pi. And then the step is equal to the period divided by 4. Okay, so 2 pi divided by 4, that's pi over 2. Okay, now it's time to start labeling. So here's the x-axis, here's the y-axis. In this case, I'm going to go up to 3 and down to -3. Okay, so we're going to label here. Let me scoot this over. This is 3. Here's my y-axis. This is -3. Okay, and then if you want, you can add some little dashed lines just to help you stay consistent when you're drawing your graph. That can be nice. Okay, why not? And then we're going to start labeling. So I'm going to start at 0. Then the step is pi over 2. So that's the next value I'm going to label on the x-axis. I'm just going to keep adding pi over 2 until I have 5 key points. So I have 2 of them so far. 0, pi over 2. If I add another pi over 2, now I'm at pi, right? 2 pi over 2. 2 pi over 2 plus another pi over 2, that's 3 pi over 2. 3 pi over 2 plus another pi over 2 is 2 pi. So there's 5 key points there. Now, the graph is cosine. Remember, at 0, cosine normally starts up at the top of its amplitude at 1. But since we have a reflection over the x-axis, this graph is going to start at the bottom at -3. And then the pattern's always the same. So it goes from one extreme back to 0 to the other extreme back to 0. And then it completes one cycle once it goes back down to -3. Okay? And then here's the important part. When you're showing what happens past this point here, make sure you show that it curves upward. Okay? Because the graph is bounded between those dashed lines. So don't make it look like it does something else. Don't make it look like it extends out of there. Like here, this would be bad. Watch this. Ah, that's terrible. Because the graph doesn't actually go out of the bounds of 3 and -3. Okay, so you want to show, see, it's going to curve back up like that. All right, beautiful. That's only one cycle, but that's fine. The domain and range. So let's look at the graph, determine the domain. Well, it's going to extend forever to the left, forever to the right. So the domain's all real numbers. That's always going to be the case. And then the range, look here, what it's bounded between. So it's going to be between -3 and 3 inclusive, right? Beautiful. Okay, moving on. Y equals sine of 3x. So let's go through what is the amplitude equal to? So the amplitude is the absolute value of A. What's the coefficient there? It's just 1, right? Okay, now in this case, the period looks like it's been changed a little bit. So the period is 2 pi divided by the coefficient here on x, which is 3. So the period is 2 pi over 3, not 2 pi. That means this graph has been compressed. It's going to complete one cycle faster. Now for the step, you take the period and you divide by 4. So the easiest way to do that when you have a fraction, if I have 2 pi over 3 and I want to divide by 4, just think of multiplying by 1/4, right? So then we can cancel this 2 with the 4. So this is going to be pi over 6. Okay, and that's it. So what we're going to do is label our axes. So here's the x-axis, here's the y-axis. I'm going to start at 0, and then I'm going to keep counting the step. So the step is pi over 6 until I have 5 key points. Okay, so 0 is my first point. Then I have 1 pi over 6. That's my next key point. Then I have 2 pi over 6, but 2 pi over 6 is pi over 3. Then I have 3 pi over 6, but 3 pi over 6 is pi over 2. And then I have 4 pi over 6, and 4 pi over 6 is 2 pi over 3. I can list those out below if you struggle with fractions. So 0 is the first point. Then we keep adding pi over 6. Pi over 6. Then I add another pi over 6. Then I get 2 pi over 6. Then I add another pi over 6. I get 3 pi over 6. Add another pi over 6, and I get 4 pi over 6. And you always want to reduce, right? So there's pi over 6. There's pi over 6. There's pi over 3. There's pi over 2. And there's 2 pi over 3. And you always include your first one, 0. So there's our 5 points. All right, now in this case, the amplitude's just 1. So here's +1, here's -1. If you want to draw some dashed lines, go for it. The graph lives in there. And then just check. So in this case, we're graphing sine. So at 0, sine starts at 0. And then there's been no reflection, so it's just going to go up, back to 0, down, back to 0. Okay, and then add arrows to extend. So it's going to go this way, and it'll go down this way. Beautiful. Now let's list the domain and range. So the domain's going to be -infinity to infinity, and the range is from -1 to 1 inclusive. Okay, good. That's coming along nicely. Next one, -4 sine of 1/8 x. Okay, so here we go. Let's list the amplitude. So the amplitude is the absolute value of A, which is going to be 4. So don't forget, this negative means that we're going to reflect over the x-axis. Okay. Now the period, that's been changed a little bit because notice here there's a coefficient on x, right? So the period is going to be 2 pi divided by 1/8. So 2 pi divided by 1/8, we're going to multiply by 8, so that's 16 pi. So this has been horizontally stretched. Now it takes 16 pi for it to complete one cycle, not 2 pi. So a lot longer. The step, or the increment, is going to be the period divided by 4. So 16 pi divided by 4 is 4 pi. So that's how I'm going to count off all of my markers on the x-axis. All right? And then it's up to you. Label in a way that makes sense. So, you know, here's my x-axis, here's my y-axis. The amplitude is 4. So I'll call this 2, this is 4. So we're in here. And then this is -2, this is -4. Maybe add some dashed lines. Okay, and then now we're going to start counting or labeling our x-axis. So we start at 0. That's one of our 5 key points. Then the step is 4 pi, yes? So the next tick mark I'm going to label as 4 pi. And then just keep adding 4 pi till you have 5 points. You guys should love this one because there's no fractions. Look. So 4 pi plus another 4 pi, that's 8 pi. Plus another 4 pi, 12 pi. Plus another 4 pi, 16 pi. Oh, this is so fun. I can just keep going. Okay, but we'll stop. We'll just do one period. How many points is that? 1, 2, 3, 4, 5. Okay, we're done. We're done. But if you had fun and you wanted to do more, go for it. All right, so this is sine. So when we're at 0, we will start at 0. And then because of the reflection at 4 pi, I'm going to plot -4 instead of +4, right? Because of the reflection. And then back to 0. At 12 pi, we're going to plot +4. And then at 16 pi, back to 0. So there's our graph. Okay, make it curvy. Don't make it all straight and weird looking like absolute value or something. Okay, so what is the domain? Yes, it's all real numbers, so -infinity to infinity. And the range is from -4 to +4, inclusive. Okay. Looks good. Let's do one more. This has a little more going on. This +2. Let's think about our transformations back from chapter 3. When we had addition or subtraction with some constant on the outside like that, that was a vertical shift, right? So that's exactly what that's going to do here. That means we have a vertical shift up 2 units. Okay, so let's go through the rest of the process the same way. So the amplitude, that's the absolute value of -3, so that's 3. So that negative means we also have a reflection over the x-axis. I mean, they're just throwing everything at us. I love it. The period is 2 pi divided by the coefficient of x, divided by pi over 4. Now watch this. The pi's are going to cancel, right? 2 pi divided by pi over 4. That's 2 pi times 4 over pi. So the pi will cancel, and we're just left with 8, okay? And that means the step, which is the period divided by 4, is going to be 2. So when you're labeling, you're not going to have multiples of pi. It's just going to be, oh, where'd my 2 go? 2. Right, you're going to count by 2s. Okay, and then we're going to shift up 2 units. So what you want to do is set yourself up, since we're shifting everything up 2 units, and then let's see, the amplitude is 3, so I'm going to have to go all the way up to 5. So I'm going to label this by 2. So this is 1, 2, 3, 4, 5. I'm going to draw a new dashed line at y equals 2. That's going to represent the x-axis being shifted up 2 units. Okay, so that's kind of like your new 0 line. And then the amplitude is 3. So from there, I'm going to count up 3 units, up to 5, draw another dashed line. And then down 3 units from 2, that'll take me to -1. And I have another dashed line here. Okay, so the graph is going to live between -1 and 5. Don't go out of those bounds. All right, and we're graphing cosine. So let's label the x-axis. So we'll start at 0, and the step is 2. So 2, 4, 6, 8, 1, 2, 3, 4, 5. Those are my 5 key points. Okay, so here we go. Starting off, when x is 0, remember cosine normally starts up at 1. But since we're reflecting over the x-axis, then it's going to start at its minimum value. So when x is 0, I'm going to plot y equals -1. Okay, then when x is 2, I'm going to come to the middle line, right? What used to be the x-axis, but it's gotten shifted up 2 units. Then when x is 4, I'm going to go all the way up, plot at y equals 5, back to 0, which is 2, and then all the way back down to -1 here. Okay, so here's one complete period, one complete cycle. And see how I turned up the ends to show it didn't go out of bounds. And then let's list the domain and range. So the domain is negative infinity to infinity, all real numbers. And the range this time is from -1 to 5. So since it was shifted up 2 units, the range also reflects that. Okay, nice job. So practice these, and then in the next section, we're going to graph the remaining 4 trig functions. So stay tuned.